So we are going to learn more about how to define and handle the matrices. A vector and a matrix. Separating a column, use blank or comma. Separating a row, use semicolon, which we already covered in the previous one. Here, what's the difference between the multiplication and period multiplications? Okay, multiplications, means the typical matrix calculations, as I computed in the previous slides, right? If we just go back for a second, this is the typical multiplications. This dot multiplications is array-based matrix calculation. Array-based matrix calculation. What does this mean? Okay, let's see. So here, A is 1, 2, 3, 4. So 1, 2, 3, 4. This 2 by 2 matrix. Okay. If we do 1, 2, 3, 4, then it's going to be just long column vector. Column vector means that these two vectors are concatenated. Okay, means that these two vectors are linked. 1, 2, 3, 4, and these are the 2 by 2 matrix. How this was possible? Because of the semicolon, right? So, and B is 4, 3, 2, 1, right? Just in the reverse order. And matrix multiplications, right? So how we get this 8? This is equal to, let's see, 1 multiplied by 4, right? And plus 2 multiplied by 2. This make 8. So this is how we got this, right? So 5 is 1 multiplied by 3 plus 2 multiplied by 1, right? So these are basic maths, right? But what makes things so special here? Dot multiplications. Dot multiplication. Actually, this is coming from the multiplications at the exact locations. So this 4 is just 1 multiplied by 4. And this is coming from the 2 multiplied by 3. Means that it's just computing the 1, 2, 3, 4, 4, 3, 2, 1, write this, and write this, and write this. It's not a regular matrix multiplications. It's just multiplying scalar values at the array indexed locations, right? So we are pinpointing a certain cell in a matrix through the dot multiplication matrix, dot multiplication operation. Okay, so that's the difference. There is a difference between these two. So then how can we specify which cell is going to be used in the multiplications or the operation, right? And we can use this. You can specify the variable matrix name here and use the parentheses at the both sides and use comma to distinguish the index, and this is the row and column, right? So this A12 is equal to 2 and A21 is equal to 2. A12 is here and B21 is here, so it's going to be 4, right? And then what does this colon does? Colon is the whole, right? The everything is the iterations. So we have A1, A1, 2. And if we want to specify this 1 to as an iteration, as a sequence, then we just say A1, comma, colon, right? And then what we get is the A11 and A12 values, which are going to be the 1 and 2 here, right? And then similarly, we have A11 and A21, right, in our A matrix, matrix A. Then this is A, the colon, comma 1, which is the 1, 3, right? So it's very easy. So I'm guessing that now you understand the difference between the matrix multiplications and the array-based multiplications. Same, the slash and dot slash, right? Dot plus and dot minus. There is no such operation. Why? Why? Because it is not needed. Plus, matrix plus is same to the matrix dot plus operations, and matrix minus is same to the matrix dot minus operations, right? So we have this dot slash operation, and here we have A 1 2 3 4 1 2 3 4, and 1 divided by A it's not going to work because the matrix dimension doesn't match. Division is just another way of doing multiplications, right? So dimension should be matched. If we are not going to match the dimension, then actually we can perform the array-based matrix multiplication or array-based matrix division, right? Here we put dot here, then we still have 1 as the scalar value, but as actually what we can get is the 1 is 1 divided by 1, this is 1 divided by 2, and this is 1 divided by 3, and this is 1 divided by 4. Okay, so this becomes a matrix, right? 1 1 1 1. Okay, but this is a scalar value. Anyhow, so we can use, I need some eraser. Okay. And so we can use colors for this color-based matrix multiplication or division. But if we want to do some real matrix division and multiplication, we have to match the matrix dimensions. And if we are going to talk about the matrix, then we have to know there are certain special types of the matrix. For instance, the identity matrix. So identity matrix is the basic matrix that you have to run whenever you deal with the matrix. So what's the identity matrix? Identity matrix results in the same matrix if A multiplied by I, then it becomes A. So these are same, right? So it's called identity matrix, right? So how we can define this kind of identity matrix is very simple. I0, I2. If you just type in I2, like this, then you will get the two-dimension identity matrix, right? And if you say 3, then it's going to be 1 1 1 0 0 0 1 0 and 0 0 1, right? This is coming from the I3. So this 2 and 3 defines the size. Okay, and this identity matrix is always this scalar matrix, so that we don't need to specify the column vector or row vector. We don't need two numbers, we just need one size to define this scalar matrix, right? And then if we have this identity matrix, actually we can use this identity matrix to the matrix division, right? Then we can do the matrix division. And this is the result. And this is the I divided by A, right? And then we get this matrix. Let's call it, this is a B, right? Then what happens if this is the B matrix, right? A multiplied by B matrix. Then A, right? And then we can cancel this and we will get the identity matrix. And to make sure that I did that operations, and we get the identity matrix, right? Here. So now we see that this division, matrix division, works fine, right? If we apply this method to the array-based matrix operations, right, the dot slash, right, then actually it doesn't work because that is not based upon matrix multiplication, right? So this is based upon the matrix multiplication. This isn't. So that's why we get this weird number here, right? Right. So this is the basics of the matrix operations. And we now find out that we have special matrices, and this identity matrix and zero matrix means that we have a bunch of zeros here, right? This 3 defines this row size, and this 2 defines the column size, right? And the ones we can have the 2 defines the row size, this 3 defines the column size, right? And diagonal matrix is 1, 2, 3. And because diagonal matrix is going to be the square matrix, we just need the vector, right? That defines the diagonal. And the random matrix coming from the uniform distribution, right? Like this. And 2 is defined here, 2 is defined here. And random matrix coming from the normal distribution is 3 and 3. This 3 comes here, and this 3 comes here, right? And then, after defining these whole interesting matrices, we can use colon. We can use colon to specify the sub-range, a part of the matrices. For instance, if we are interested in only this part of this A matrix, what you can do is that A1, so we are interested in A1, actually, what's this is A1, 2, A1, 3, A2, 2, A2, 3. And how to represent this is like this. So we have 1 and 2. So 1, 2 iteration, comma, we have 2, 3. 2, 3 iteration, right? And A. So this defines this subsection of this matrix, right? You can see how it works here. So, right, doing matrix maybe feel like that you are you return to your middle school days. But actually, matrix multiplication, matrix division, and matrix operations are the basics of the multivariate statistics. So this is pretty important for your ISC studies. So I'm just trying to motivate you to study this. So it's very tedious part of this lecture, running the tools, right? If you learn how to play the piano, probably you there at the beginning of playing the piano, you have to do some practice, right? Do re do re do re do re mi fa sol do re mi fa sol do. Just make your finger move on the piano. this is the same, right? You are new to the programming, then you have to move your fingers, and then after a while, you running these stuffs, and then you get to play some interesting stuff, right? So before doing so, people will reach that point. Just be patient a little bit, okay? And actually, these concatenations we already discussed already, right? So we have this 1, 2, 3, 4, and 1, 2, 3, 4, and JIT1 is doing actually this. And bracket 1, 2, bracket, small bracket, 3, 4, and this. And what happens here is the concatenating the whole vector. So what it returns is, right? Unless you don't, if you have this semicolon here, is going to be 2 by 2. If you don't have this semicolon, it's going to be 1 by 4, right? Like this. So if we have semicolon, it's going to be 2 by 2. And we have this identity matrix. And what happens here is that by using this colon, what we are doing is that we are just going through these 2 by 2 matrices, right? So this one is coming from the 1, 1, this is coming from 1, 2, 1, 3, right? 2, 1, and 2, 2, and so forth. By using colon alone, what you can do is that turning your 2 by 2 matrix a row vector, a n by 1 vector, right? And then what you can do is reshaping this y vector and turn into 3 by 3. This 3 comes here, and this comes here, and then you can completely reshape this your row vector or column vector, right? And then after that, what you can do is the replications. We have 1, 2, 3, 4, right? And then we are going to replicate x with this many times, right? The 3 time replications, and this 2 means the 2 time replications, all right? So 2, 2, 3, 3, 3. So this is the replicated matrix, okay? These are all interesting matrix manipulations.